Alright, so Algebra 1, Chapter 9.6 is taking 9.1 through 9.5, combining them all together and helping you decide which one of those methods should I do. Should I just factor it like I learned how to do in Chapter 7 by finding the GCF, doing trial and errors, the perfect square trinomial, is it a difference of perfect squares? Or should I extract the root? Should I use complete the square, or should I use quadratic formula? So up to now, every section told you how to do it. It said to solve by completing the square, or solve by extracting the root, or solve by finding the difference of perfect squares. So now it's just going to give you random problems, and you have to decide which way to do it. One's going to be the easiest. To be fair, you could use, in this case, if it doesn't tell you which way to do it, you could use the quadratic formula every time, and it would work, but it may not be as fast as using the other ones or as efficient. All right, so you want to get to where you can use any of them, just like I could use a socket to take a nut off, or I could use a winch. Sometimes one or the other is going to be better than the other depending on how much space I have and how it will affect how fast I can get that job done. These are tools that you're going to have in your algebra toolbox that you get to decide when to use and when is the most efficient to use that certain tool. So choosing a method. First of all, if it's a pure quadratic, if it's missing the linear term, if it does not have an x term, a bx, I'm going to extract the root. Sometimes, depending on how it's written, I'm going to factor by the difference of perfect squares. But for the most part, if it gives me something like x squared minus 9 equals 0, I personally am going to do x plus 3, x minus 3 equals 0, and I can see that it's going to be x equals plus or minus 3. All right? But if it gave me that same problem as x squared equals 9, they just move that 9 over. In this case, it's faster just to take the square root of both sides or extract the root. I know that I'm going to get x, and over here I'm going to get plus or minus the square root of 9 is 3. All right, so I got the same exact answer on both of them. When it was written like this, it was faster for me to see that that's a difference of two perfect squares, factor it, solve it. When it was written as x squared equals 9, instead of subtracting 9 over and then factoring, I just take the square root of both sides and I solve it. And I get the same exact answer both ways. All right. So, and again, I could have taken this and said my A equals 1, my B equals 0, my C equals negative 9, and I could have plugged it into the quadratic formula, and I still would have got plus or minus 3. But there'd have been a whole lot of steps to where I'm already done with it 2 times. I'd still be working on it if I didn't have the quadratic formula. All right, so if it's a pure quadratic, if it's missing the B term, I'm either going to complete or factor by difference of perfect squares if the C term's on the same side. If it's on the opposite side, I'm going to extract the root. All right. If it's not missing the B term, then I'm going to rewrite it in standard form. I'm going to get it set equal to 0. So something like that would be 3x squared plus 10x minus 8 equals 0. In this case, it's not missing the B term. I have a 10 in place of B. I'm going to make sure it's in standard form. It is set equal to 0, so it's in standard form. If B is not 0, it has a B, then I'm going to try to factor. I'm going to do trial and error. I know that 3x squared has to be 3x and x. I know my signs are going to be opposite. I don't really know which spot they're going to be yet. I know I need the outside times the outside plus the inside times the inside. I know I need those to equal positive 10. So I'm going to look at the factors of negative 8. Generally, you should be able to do this part in your head, but just so you can see it on the board. That's negative 1 and positive 8, positive 1 and negative 8, negative 2, positive 4, positive 2, negative 4. I will always pick the two that are closer together to start with, and if they don't work, then I'll move out. I know I need it to be positive. So I need, when I add the outside and the inside, I need it to be positive, which means the positive that I'm about to have a plus and a minus that I've got to use. positive is going to be to the side that's larger, all right? So I'm going to try, let's do positive 4 and negative 2. I picked the positive 4 because I know I need it to be positive. 3 times positive 4 is a positive 12. Chances are I'm going to get a positive number. The outside times the outside, 3x times positive 4, let me make sure I have the x on there, is going to be 12x, plus negative 2 times x is negative 2x. Positive 12x plus negative 2x equals 10x. I'm good. This is the factored form. Then I have to solve, so I know I'm going to get this factor set equal to 0. I mean, this factor set equal to 0. And then I'm going to solve each one of them. 3x equals positive 2 divided by 3. X equals 2 thirds. Over here, I'm going to subtract 4 from both sides. X equals negative 4. So I got negative 4, positive 2 thirds. I knew I was going to get 2 answers because it's quadratic. So in that case, that one wasn't too bad. It could have taken me longer. I could have put the positive, I could have made it positive 2 and negative 4. I would have got close. I'd have got probably negative 10x or negative 12x or whatever. I could have tried the 4 over here and the 2 over here. So there's different ways I could have done trial and error. Once you've got enough practice, you're going to kind of see where you're going before you go and have a good idea in what direction. You just got to get practice on that part. All right, so that one was factorable, fairly easy. If it can't be factored easily, then we'll go with complete the square. So if I have something like, or complete the square or quadratic formula, 5x squared minus 3x equals 1. First step, is it a pure quadratic? It's not because it has a b term. Since it has a b term, I'm going to set it equal to 0. 5x squared minus 3x minus 1 equals 0. I'm going to try to factor 5x and x. My sign's going to be opposite the prop. Let's see. 5x. Yeah, there's no. So I know that this has to be 1 and 1 because the last times the last has to equal 1. The signs, if I do 5x times positive, I get positive 5x. And negative 1 times x is minus x. That's 4x. I need it to be 3x. So there's no way I'm going to get to 3x just factoring. So at this point, since it's not going to factor easily, I need to decide, do I want to complete the square or do I want to use the quadratic formula? The way I'm going to decide really easily, 2 things that I'm going to decide. One, b is an odd number, so I know when I take, if I go to complete the square, I've got to take half of b squared, right? If this is odd, that means I'm going to be dealing with fractions because I'm going to get 3 halves squared, which is 9/4, and I'm going to deal with fractions. If this was even, I might consider completing the square. Because it's odd and there's a bigger coefficient, I'm just going to use quadratic formula. So my a is equal to 5, my b is equal to negative 3, and my c is equal to negative 1. I've got to be careful. I can't use the original one because it's not equal to 0. I've got to make sure my c is over here before I decide if it's positive or negative. So now I've got negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to start plugging them in. Negative, instead of b, I'm going to have negative 3 plus or minus the square root of, instead of b, I'm going to have negative 3 again, minus 4 times a is 5, c is negative 1, all over 2 times a is 5. Negative 3 is positive 3 plus or minus the square root of negative 3 squared is 9, minus 4 times 5 is 20 times negative 1 is negative 20 over 10. 3 plus or minus the square root of 9 minus negative 20 is plus positive 20, 29 over 10. 29 is prime. So there's no way that I can split it up. There's no factors of 29 that are perfect square. That's as far as I can go. So x equals 3 plus or minus the square root of 29 over 10. Perfectly acceptable answer. Not the way we like our answers to look in the past, but now that's just going to be that's going to be perfectly normal. Well, let's look at one more thing. When we talk about the quadratic formula, let's talk for a minute about, I'm going to change the color of this. Let's make it bright orange. B squared minus 4AC. The part that's under the radical in the quadratic formula is called the discriminant. So the discriminant is equal to the b squared minus 4ac. So there's three different scenarios that we could get whenever we find out what b squared minus 4ac is. All right, if it's positive and a perfect square, that means that it's factorable, and I'm going to solve by factoring. If it's positive and not a perfect square, that means that it's not factorable, and I'm going to use quadratic formula. All right, if the determinant is negative, I can't have a negative under a radical. I cannot have the square root of negative 4. So that means that the determinant is, or the answer is no, what I just have to do, no real solution. All right. So before I even go too far into it, whenever I start to factor one of these, if I just look at the b squared minus 4ac, when I get to that step, if it was the square root of 25, that's a perfect square, that's factorable, I'd solve it by factoring. If I got the square root of 26, that's not a perfect square, I would use the quadratic formula. And if I got the square root of negative 4, there's nothing that you can multiply by itself and get negative 4. That would be no real solution. All right, so before you decide which one of them you want to do, if you'll look at the b term, square it, and subtract 4 times a times c from that, whatever number you get, if it's a perfect square, just factor it. Don't use complete the square or quadratic formula, just factor it. If you get a non-perfect square, use the quadratic formula. If you get a negative number, don't waste your time. There's no real solution. There's nothing you can do. All right, anything else in this section? That gets you through 9.6. That's the end of the chapter. Nope, it's not. So that gets you to 9.6. We'll look at 9.7 when we come back.